Okay, we are back with some quick math. We are dealing with some technical math. This is functions, and let's get straight into it. Like the videos, subscribe to the channel, and share it with anyone doing technical math, grade 12, or even grade 11, pure or technical math. This will be beneficial to all of them. Okay, so in the picture that you see, there is two functions, right? There is f and there is g. Okay, so when you look at that, you already see that f is quadratic. There's a square there, and then g is linear. Okay, there's no square, and x is to the power of 1. Okay, so you look at the picture, this over here, that is your quadratic is your parabola, linear is your straight line. Great, so those two functions are there. We see that they meet at a is the x-intercept of both, or rather the x-intercept of both functions. We see b over there. C is our turning point, and there's a point t where they also meet. Okay, great. So we're gonna skip through the definition. If you need it, go read through it, but let's get straight into the questions and let's see what we can solve. Right, so the first thing is to determine the x coordinate of a. So that's what we want over here. So let's look at what we have. The parabola, the quadratic function, there is a complete list of unknowns, so you have no information. You can't use your quadratic. Okay, let's look at the linear function. Okay, great, the linear function is complete. So you can use your g of x in order to find this point over here, because g of x touches a, and g of x is, well, a is your x-intercept. A is your x-intercept of g. Great, we got that right. Okay, so we're gonna take our function g of x, right, and that is x, and we're gonna say minus x minus 2. So we know at your x-intercept your y values are 0. At your x-intercept your y values are 0. What does that mean? Everywhere on this line, all of these y values, whatever these y values will be, all of those, wherever I made those red x's, the y value on all of those dots are 0. Okay, by nature of it being the x-axis. So in order to find this point over here, you are going to make y 0. Now we don't see a y here, but we are comfortable with function notation enough to know that that whole thing represents our y. So we will say y, which is that, right, is 0, is equal to negative x minus 2. And now you want to solve for x, so we are going to take this thing to that side, and that will give us a positive x equals our negative 2. Okay, so that is a 2, negative 2. What does that mean? That means this coordinate, your x coordinate rather, for the a is minus 2. 4.1.2, show that k equals 1. Now whenever they give a show that question, and I think they give it here again at 4.1.4, the show that, you are not allowed to use the information given to prove that k is equal to 1. You can't use the fact that k is 1 to prove that k is 1. So they're basically saying find k. We are telling you that it's gonna be 1, so we know the answer, but you must find k. Right, so where's k? K is over here. What we see there is okay, great, this is easy. They give us the y value, which is minus 3. This falls on our straight line. Okay, so you want the x value for your linear function when x is minus 3. So again, we're going to go back to this formula, this equation, and we're going to say g of x. Okay, so the y value is minus 3. This whole thing, as we said, is going to be your y value. So we'll say minus 3 is equal to minus, now what's the x value there? The x value there is your k, right? So we're gonna say minus the x value is the k, so it's minus k, and the minus 2 comes from the equation. So now we need to just solve for k. Let's take k to that side, the left hand side, and let's take this to that side, right? So we understand you're adding k on both sides, so you have a k equals, and you're adding 3 on both sides, so you have a 3 and that minus 2, so that is equal to your positive 1. That's equal to your 1. So show that k is 1. Okay, we did that, right? We didn't use the fact that k is 1, but we found k, and we found out that it is equal to what they said it should be. Okay, determine the coordinate for b. So like if we look at our picture that we have, right, we have a quadratic function, quadratic parabola. A parabola is symmetrical. What does symmetrical mean? It means that on the one side it is equal to the same thing on the other side, right? We have this line, which is that dotted line, the C line. You have this line, right? This line is our axis of symmetry, right? So that tells me on this side of the line and on this side of the line, your parabola is symmetrical. It looks the same on that side and on the other side. Why is this important? Because whatever I'm going to do from this point A to get to that point, I will have to do the same thing from this point to get to that point, right? Because it's symmetrical. So yeah, at A, what is the x value at A? We found it was -2. What's the x value or the dotted line that you have over here? We found our k value to be 1. So if I go from here to here, okay, from -2 up until +1, that's about 3 units. Okay, where did I get my 3 units? I said my 1 minus my -2. Okay, so I took the 1 x value and I subtracted the other x value. Minus is a plus, so 1 plus 2 is 3. Okay, so in order to find this space between those 2 points, I took your 1x and I subtracted your other x, right? Even if you had to swap those around and say 2 minus 1, you're going to get -3. But all that is telling us is that the space from A up until this dotted line is 3 units. Similarly, or rather, if it is 3, then it should be 3 on this side as well. So the 1 plus the 3, and that will be a 4. Okay, so the x coordinate of b that we found out was going to be 4. Great. Okay, show that again. Show that question, right? So we need to use our information above to prove that f of x is equal to that function. Let's leave that for the next video. I don't want this video to go on for too long.